Thank you very much, Mr. Numan Zahid. Our next presenter is Muhammad Tayyab from College of Hydraulics and Environmental Engineering, China, 3 Gorge University. Uh, Mr. Tayyab will present stream flow prediction by applying artificial neural network with different input variables. So with this, I request Muhammad Tayyab to please present his paper.
Hold on, sir. Hello, everyone. Can you see my screen?
Yes.
Okay, sir. So, thank you very much for inviting me and giving me a chance to present my work in ICHWR 2022 conference. So, topic is stream flow prediction by applying artificial neural networks with different inputs variables. So, slides have my presentation includes 6 contents: introduction, study area, objectives, methodology, results, and conclusion. Starting from introduction, Earth's average global surface temperature is increasing and it has risen about 1 Fahrenheit in last century and expected to go up another 3 to 11 Fahrenheit in next 100 years. Different researchers have done researches on this, so they have given this a window that temperature will be risen between 3 to 11 Fahrenheit. The climate change has been dubbed as global warming, although the magnitude of the warming may seem insignificant, but many natural processes have been profoundly affected. For example, a number of changes in the water cycle have been documented and many more are under investigation. Global warming intensifies the movement of water through the cycle because many of the processes are involved are temperature dependent. Changes in the temperature and the precipitation pattern increase the frequency, duration, and intensity of other extreme weathers, such as floods, droughts, and heat waves, and some other natural hazards. So the selected study area for my research was Yangtze River, the upper part of Yangtze River, which is known as Jinsha River Basin. Jinsha River Basin uh, has a length of 2,316 kilometers and it covers around 340 into 10 raised to power 3 kilometers square. And the average flow is 149.8 billion meter cube. So the objectives of my research area or my research work are divided into 2 sections. First are the questions, and the second will be the aims. So my research questions are: what kind of forecasting will be justify its status? Many people are doing their researches on the same area. What will be the difference? How I can justify my research work as compared to others? And what kind of data will be available, what kind of data set I will use. Some people will use only precipitation data, some will use discharge data, maybe some other people will use, other researchers will use temperature data. So what kind of data I will use or data set I will use, and what kind of model should be selected? There are many available models, like we have ANNs, we have other physical models. So what are, why we are using ANNs, and how it justifies our research, and what parameters are required to establish the models. So these are my questions, and my research aim is to enhance the importance of model selection for the specific research area, to improve the model with respect to specific situation, to reduce the uncertainty factor, changes of climate factor, and its effect on the stream flow at Jinsha River Basin. And my methodologies which I have used are numerous, like ANN has feed forward, RBF, GRNN, and then I have used some decomposition methods like DWT and EEMD, discrete wavelet transform method, and ensemble empirical mode decomposition method. So I have first step is to select the inputs. For that, I have used ACF and PCF method, autocorrelation function and cross correlation function. So here we have selected the inputs based on ACF and PACF. And for model input performance, the selection criteria, we have used 5 different indices to check how our model is working, or which model is best for this particular research. So for performance evaluation, we have developed different models based on their inputs. Like in one model, I have used only discharge, and in other model, I have used discharge, temperature, and precipitation. Like the models in which I only have used discharge models, they are called as runoff models. But the other in which I have used discharge, temperature, and precipitation, I have called them rainfall runoff models. So in this case, first we have only selected ANN models like BP, RBF, and then we have used decomposition methods like DWT and EMD to decompose the method and to check whether this composition method will enhance the results and will enhance the performance of the ANN models, which we are using only as a single model. So as you can see in the calibration phase, that for BPQ, which is known as, or all the models which are only using Q, or they will be considered as runoff models. So runoff models are performing less better as compared to those which have QTP, like 3 inputs. QTP means, Q means discharge, T means temperature, P means precipitation. Like if we are using if we are using more inputs to the model, or we are giving more inputs to the model, our model will be more better. And by if you look first 4 model, BPQ, BPQTP, RBFQ, and RBFQTP, and then we apply DWT, decomposition method, to these, you can see for the first one, BPQ has R value of 0.71. But if we apply DWT decomposition method, uh, it will give more better result as compared to single ANN model. Similarly, between decomposition methods, EEMD and DWT, EEMD is performing more better. In validation phase, you can see all the indices are RMSE, Nash efficiency, MAP, and MAE. All indices are showing that models with ANN are also are giving better results. But if we are using more inputs and we are applying decomposition methods, our results will improve. In MEA, you can see for BPQ, the value is 2416, and it reduces up to 1074. Similarly, we have drawn these results as a runoff hydrograph, which are showing results between observed values and BPQ and BPQTP. BPQTP are showing better results, and they are capturing lower values as well as the higher values as well, both in calibration and both in validation phase. So in this case, you can see that if we are applying decomposition methods, they are showing better results as compared to those in which we have only used the single ANN models like RBF or RBF, GRNN, or FFBP. So by using more inputs and by using decomposition methods, we can improve our results. So in conclusion, it is written that it comes that results are improved by adding the temperature and precipitation to the model as input. All models, which includes QTP as input, has performed with great accuracy. FFBP, QTP, RBF, QTP, and DWT, FFBP, DWT, RBF, QTP, and EEMD and EMD. All these models based has performed better. Applied neural networks such as only single network like FFBP and RBF has shown better results as compared to FFBPN. So individual basis RBF on individual basis between FFBP and RBF with more inputs have performed better results. Among applied decomposition methods, EEMD has performed better as compared to DWT. In comparison with all the models which have more inputs, they have performed better as compared to only one input. So so the optimum model for Yangtze River or Jinsha River Basin is EEMD RBF QTP, which is our optimum model. Thank you very much for the listening.
Thank you very much, Mr. Tayyab.